Solving rational equations. A rational equation is an equation containing at least one rational expression. A rational expression is something with a numerator and a denominator where it has a variable in the bottom. So here we have two examples of rational equations. To solve a rational equation, we're going to start by factoring each denominator if possible. We're going to identify any non-permissible values, multiply both sides of the equation by the lowest common denominator, and then solve by isolating the variable on one side of the equation. We also need to remember to check all of our answers. So let's start with this one. X over 4 minus 7 over x equals 3. It's a rational equation because of the x in the bottom in the second term. We have no factoring to do in the denominators. 4 is factored, x is factored, and so we need to start by finding the lowest common denominator. Our lowest common denominator here is going to be 4x. The next step is to multiply each term in our rational expression by 4x. So we need to multiply this by 4x, this part by 4x, and this part by 4x. If we've chosen our lowest common denominator correctly, when we multiply everything by 4x, each of our denominators should disappear. So 4 and 4 become 1, so I end up with just x times x, or x squared. This x and this x divide out, so we end up with 4 times negative 7, or negative 28. And on the right-hand side, 4 times 3 is 12x. Our next step is to solve that equation. It's a quadratic equation, and so we can solve by factoring. In order to factor, we have to make the equation equal to 0. So we're going to subtract 12x from both sides. And we end up with x squared minus 12x minus 28 equals 0. Solving by factoring, we are looking for two numbers that multiply together to give us negative 28, add to negative 12. So we will have negative 14, positive 2. We're going to take each factor, make them equal to 0. So x minus 14 equals 0, and x plus 2 can equal 0. Two possible solutions, x can equal positive 14, and x can equal negative 2. We need to state some restrictions on this equation. The restrictions come from anything that will give us 0 in the denominator. So 4 can never be 0. The only other denominator we have is x, so that means that x cannot be 0 in this question. We're going to check our answers. So we're going to start by checking x equals 14. To do that, we're going to substitute 14 back into that original equation for x. So we have 14 over 4 minus 7 over 14 equals 3. And we want to show whether or not this is true. 14 over 4 will reduce to 7 over 2 minus 1/2 equals 3. Common denominators are already there, so 7 take away 1 is 6 over 2 equals 3, which is true. So 14 is one of my solutions. I also need to check the second solution, which is that x equals negative 2. So substituting that in, we end up with negative 2 over 4 minus 7 over negative 2, and I want to show whether or not that equals 3. Negative 2 over 4 is negative 1/2. Two negatives make a positive, so we end up with positive 7 over 2. Does that equal 3? Common denominator is already there, so negative 1 plus 7 is 6 over 2. Does that equal 3? Yes. So both solutions work. We write our answer in a solution set. Our answers are negative 2 and positive 14. Solve the following rational equation. What values are non-permissible? So this one's more complicated because our denominator is more complex. To start, we're going to start by factoring each of those denominators. So factoring z squared minus 4 is a difference of squares. So we end up with z plus 2 times z minus 2 plus 10 over, this middle denominator has a common factor of 6, so it's 6 times z plus 2 equals, and the denominator of this third piece cannot be factored, so it's already in simplest form. We're looking then for the lowest common denominator. Lowest common denominator, if I start with the denominator of the first one, is going to be z plus 2 and z minus 2. Looking at the second one, what's new there is a factor of 6. And looking at the last one, there's no new factors, so this becomes my lowest common denominator. I need to multiply each of those three pieces by that lowest common denominator. So we're multiplying by 6, z plus 2, z minus 2 in each of these places. Looking for things that will simplify or divide out. The z plus 2 in the bottom and the top will divide out to be 1. Z minus 2 and the z minus 2 cancel out, and so I'm left with 2 times 6, or 12. In the middle term, the 6's will cancel, the z plus 2's will cancel, leaving me with plus 10 times z minus 2. In the last group, z minus 2's will cancel, leaving me with 6 times z plus 2. We no longer have a rational equation, so we can start continuing to solve this. We're going to multiply in our coefficients, or the numbers out front, in order to get rid of those brackets. So it's 12 plus 10z minus 20 equals 6z plus 12. To solve, I want to collect like terms. There's no squared, so I know it's not going to be quadratic, so I'm going to collect the numbers on one side, variables on the other. So simplifying here first, 12 take away 20 is going to be negative 8 plus 10z equals 6z plus 12. Let's add 8 to both sides to move it over. Gives me 10z equals 6z plus 20. Moving the 6z over, I'm going to subtract 6z from both sides. Gives me 4z equals 20. Final step, divide both sides by 4. And I have z equals positive 5. Now let's go back and check restrictions. When we're doing restrictions on this question, we need to do it after we've factored. And once we've factored, we want to make sure that none of those denominators equal 0. So looking at the first one gives us restrictions that z cannot be positive 2 or negative 2. Looking at the second denominator is negative 2, but we already have that. And the third denominator gives me a restriction of positive 2, which again we have. So the only two restrictions we have are that z cannot be positive 2 or negative 2. We need to check our answer. So we want to check to see whether z equals 5 actually works. So putting 5 back into that original equation gives us 2 over x squared, so 5 squared minus 4, plus 10 over 6 times 5 plus 12 equals 1 over 5 minus 2. So we have 2 over 25, take away 4 is 21, plus 10 over 6 times 5 is 30, plus 2 is 42, equals 1 over 5, take away 2 is 3. So we're trying again to see whether or not that is a true statement. Simplifying, I can reduce the 10 over 42 to 5 over 21, which is nice because that gives me the common denominator. So 5 and 2 is 7 over 21. Does that equal 1 over 3? 7 over 21 can be reduced to 1 over 3, and so that solution works. So my solution set is that Z equals 5. Last one for the day. Again, quite an involved equation. Start by factoring your denominator. So in the top, the 4k minus 1 stays. K plus 2 is already as factored as it can be. Minus k plus 1 all over. Again, k minus 2 cannot be factored. There's no use factoring the numerator on the right-hand side, so leave it as k squared minus 4k plus 24. But we can factor the bottom here into k minus 2 and k plus 2. Our lowest common denominator is going to be k plus 2, k minus 2. Might as well do restrictions while I'm here before I cross anything out. So restrictions, anything that will make the denominator equal to 0. Well, if k plus 2 can't be 0, so k cannot be negative 2, and k minus 2 cannot be 0, so k cannot be positive 2. So my two restrictions are that k cannot be positive 2 or negative 2. Multiplying by that lowest common denominator to get rid of my denominators. So we're multiplying everything by k plus 2, k minus 2. Now we're going to look for things that simplify out. The k plus 2 in the bottom and the top will cancel, leaving me 4k minus 1 times k minus 2. In the second group, the k minus 2's will cancel, leaving me with k plus 1 times k plus 2. And in the last group, the k minus 2's will cancel, the k plus 2's will cancel, so all I have left is my numerator. I have a wrong sign there, that should be a negative 4k. Distributing to get rid of those brackets gives me 4k squared minus 8k minus 1k plus 2. Subtract, multiplying out the second one, gives me k squared, and when I do this I get 2k, and another k gives me a total of 3k's plus 2. And nothing to simplify on the right-hand side. I can collect some like terms in this first group. So I have 4k squared minus 9k plus 2. Remember that we are subtracting all of the second bracket or adding the opposite. So it becomes negative k squared minus 3k minus 2 equals k squared minus 4k plus 24. Let's tidy this up a little bit on the left and combine some like terms. If I have 4k squared and I subtract k squared, I have 3k squareds. Negative 9 minus 3k is negative 12k. And 2 minus 2 is 0. The right-hand side, there's no like terms to collect. I have k squared, so my thought is I'm going to have to factor because it should be quadratic. So I'm going to move everything onto one side. So I can subtract k squared from both sides. I can move this 4 by adding 4k. And move the 24 by subtracting the 24. I then have 3k squared minus k squared, or 2k squareds. Negative 12 plus 4 is negative 8k minus 24 equals 0. Solve by factoring, so factor out a 2. So k squared minus 4k minus 12 equals 0. Factor the trinomial. Again, two numbers now that multiply together to give me negative 12. Add to negative 4, so I have negative 6 plus 2 equals 0. 2 can never be equal to 0, so I don't need to worry about it. If I have k minus 6 equal to 0, that means that k would be 6. And in order for k plus 2 to be 0, k would have to be negative 2. We've done restrictions, so now we just need to check those two answers. So let's start by checking k equals 6. So substituting 6 in, we have 4 times 6 minus 1 all over 6 plus 2 minus 6 plus 1 over 6 minus 2 equals, and I want to show that that equals 6 squared minus 4 times 6 plus 24 all over 6 squared minus 4. So you'll notice that I substituted 6 into that very original equation before we canceled anything out, and I want to show that that statement works. So 6 times 4 is 24. Take away 1 over 6 plus 2 is 8, minus 6 plus 1 is 7 over 4, equals 6 squared is 36, minus 24 plus 24, all over 36 minus 4. So simplifying, 24 take away 1 is 23 over 8, minus 7 over 4, equals negative 24 plus 24, those cancel, so I have 36 over 32. So I want to show that those two actually equal. Finding a common denominator, I would have to multiply this term each by 2. So I'd have 23 over 28 minus 14 over 8. And I want to see that this is 36 over 32. 36 over 32 are both divisible by 4, so we end up with 9 over 8. 23, take away 14, is indeed 9 over 8. And so that solution works. So that solution was, we were checking the value of k equals 6. We still need to check our other answer, which is k equals negative 2. Now, if you substitute it in and check it, you will find that it doesn't work. How do I know this? Because back when we did our restrictions, we said that k could not equal negative 2. Because k cannot equal negative 2, I know that this is extraneous. That's what we call a root that doesn't work. And so the only acceptable solution is positive 6.